Welcome to The Explainer. Today, we are diving into something you might not think about every day, the most abundant state of matter in the entire universe. And no, it's not just something out of a sci-fi movie. This stuff is what stars are made of, and it could, quite literally, be the key to our future.
All right, so let's jump right in with a question that might just flip what you learned in high school science class on its head. When you think about the states of matter, what comes to mind? Probably solid, liquid, gas, right? Well, what if I told you that all those things we see around us, they're barely a drop in the cosmic ocean?
Yeah, the answer's pretty mind-blowing. It's not solid, liquid, or gas. The most common state of matter makes up over 99% of the visible universe. We're talking about a superheated, electricity-charged state called plasma. It is, for all intents and purposes, the stuff the cosmos is made of.
So here's what we're going to cover. First, we'll go beyond the big three, solid, liquid, gas. Then, we'll figure out how you even make plasma. We'll take a tour of the cosmos to see where it's hiding in plain sight. And finally, we'll get into the really cool part, the incredible quest to build a star right here on Earth.
All right, let's get into it. How did we even figure out there was a fourth state of matter? Let's go beyond the ones we all know and love.
You know, the history here is actually pretty fascinating. The name plasma was first used way back in 1923 by a physicist named Irving Langmuir. He saw that this energized gas carried all these different charged particles around, kind of like how blood plasma carries red and white cells. And you know what? The name just stuck.
Okay, so if this is a real state of matter, how do you make it? I mean, what does it actually take to transform a normal, everyday gas into this exotic, super-energized stuff? The easiest way to think about it is like this. Just keep adding heat. You start with a solid, right? Like ice. You add some energy, heat, and you get liquid water. Add more energy, and it turns into a gas, steam. But what if you don't stop there? What happens if you keep cranking up the energy? Well, things get wild. The atoms themselves get smashed so hard they actually break apart.
And that critical moment, that tipping point where a gas becomes a plasma, it's got a name: ionization. It's just the process of pumping so much energy into an atom that you literally knock one or more of its electrons right off.
This image here really gets to the heart of it. Once you've ionized that gas, you're left with this hot, chaotic cosmic soup. You've got positively charged ions, that's the bits of atoms left behind, and negatively charged electrons, and they're all just zipping around freely. It's this sea of charged particles that makes plasma so different from a regular gas. It can conduct electricity, it responds to magnetic fields, it's a whole new ballgame.
So, we know what it is and how to make it. Now, where do you find this stuff? Well, turns out, while it's kind of rare here on Earth, for the rest of the universe, it's pretty much the default setting.
Is funny, our cozy little planet is actually the odd one out. In most of the universe, it's just too hot and too energetic for atoms to stay in one piece. So, for something like the Sun or any other star, plasma isn't just a state of matter, it's the only way matter can even exist.
And you don't even have to look that far to see it. Think about a bolt of lightning. That's plasma. Or the incredible northern and southern lights. That's plasma too, created when solar particles hit our atmosphere. It's in the radiation belts that protect our planet, it's in the ionosphere, and yeah, of course, every single one of those twinkling stars in the night sky is a massive ball of plasma. But here's the thing, it's not just sitting there. Inside these giant plasma spheres we call stars, the conditions are so extreme that they become cosmic engines. They're actually powering the entire universe through an absolutely incredible process.
And that right there brings us to one of the most exciting, most ambitious goals in all of science. What if we could take that stellar power and build a star on Earth?
So how do stars work? What makes them shine? Well, at their core, they're taking the simplest, lightest element there is, hydrogen, and under unbelievable heat and pressure, they're literally smashing the atoms together to create helium. This process is called thermonuclear fusion, and it unleashes a truly staggering amount of energy.
And this is the very first step of that process. Right here in this equation, you can see it. Two hydrogen nuclei, which are really just single protons, are forced together in the sun's core. That one little reaction kicks off a whole chain that ends up creating helium and, of course, a massive amount of energy.
And when I say massive amount of energy, I'm not kidding. The full reaction releases something like 28 million electron volts. Now, an electron volt is a tiny, tiny unit of energy on its own. But when you have trillions and trillions of these reactions happening every single second, well, that's how you get the power of a star.
So that leads to a really big question, right?
If we know how stars do it, and the fuel they use, hydrogen, is the most common thing in the universe, why don't we have fusion reactors everywhere? Why aren't we all using this clean, limitless power?
Well, it's because building a star in a box is, without a doubt, one of the hardest things humanity has ever tried to do. The conditions inside the sun's core are, let's just say, they're a little tough to recreate here on Earth.
It really boils down to two huge challenges. First, you need insane levels of heat. We're talking millions of degrees Celsius just to get those atomic nuclei moving fast enough to overcome the fact that they naturally want to repel each other. And second, you need confinement. The sun uses its own massive gravity to squeeze everything together. We can't do that. So we have to figure out a way to contain that scorching hot plasma without it ever touching the walls of the reactor, because it would just vaporize them instantly.
But this isn't just science fiction. This is real. As this quote points out, achieving this is the primary goal of plasma research all over the world. Right now, thousands of brilliant people are dedicating their lives to cracking these problems.
And that really leaves us with one final, huge thought. From a flash of lightning to the heart of our sun, plasma is everywhere. It's the fabric of our universe. And if we can learn to understand it, to master it, well, it could change everything. It could unlock a future with clean, safe, and practically limitless energy for all of humanity. So the ultimate question really is, can we finally build a star?